So hello everyone, in this video we are going to solve the questions of exercise 16.3, right? Question number 11 here. So see, first of all read the question carefully. In a lottery, a person chooses the 6 different natural numbers, right, and random from 1 to 20. Okay. So here we have 1 to 20 numbers and a person has to 6 any 6 natural number from there randomly. Right. If this 6 number match with the 6 number already fixed earlier by the lottery committee, he win the prize. Okay, got the question or not? We have 1 to 20 total. We have to select in a 6 number from there, and 6 number already fixed by the lottery committee. Yes, if a person get this 6 number, then they will win the prize. So what is the probability that a person will win the prize? Right, a person is going to play this game. So what is the probability that he will win the prize? Now see, important thing is what here? Order is not important here, right? Means let us suppose one person selecting 1, 2 here, 1, 2, 3, 4. Just example I'm saying 1, 2, 3, 4, 5, 6. Or one person selecting here 2, 1, 3, 4, 5. So both are same actually, right? So you are selecting the number in group. So not like that you are arranging and you are finding that number. No. Simply if you are getting this digit, that fixed digit, then you will be getting that price. So these both are the same case. Means order here, see, one we get in the first, after that second. But here one we are getting in the first, two we are getting in the first and one in the second. So both are same thing actually. So order doesn't matter here. Fine. So see how we can do this. So first of all, let me write the total number of case. Okay. So see, here we have total 20 case, and if you want to select any 6, so how many way you can select? 26, right? In the combination chapter we have learned this. Okay. So how many here? Let us write down. So solution. So total number of ways. Total number of ways to select 6 different number, to select 6 different number or natural number from given 20 number, from number 1 to 20, right? We have actually total 20 number, 1 to 20 here we have, and we have to select any 6. So how many way we can select? Simply NCR formula, we have total 20 and you want to select any 6. So 20 C6, so simple. So this is the total number of possible outcomes. Means this way a person can select 6 number out of 20. 20 C6, right? Now, that 6 number, whatever is fixed, that is only one way. Let us suppose a fixed number is something 2, 4, 5, 6, 7. So that is the fixed number. 2, 4, 5, 6, 7. If one gets, then he will win the prize. So number of favorable, right? So let us write E, right? So number of favorable outcomes. So whatever is fixed by the lottery committee, that is only one way. If once they fix, they are not going to change it. So that is fixed, only one way. So that is only one way to fix that one. So now what is the probability of this one? So if you want to find the probability of winning, right? So what is the probability of winning? Probability of winning the game. That is the in the favor. So in the favor you have only one, that is the fixed number by the fixed committee divided by total number of possible ways that one can get. So 1 upon 20 C6. If you are solving this 20 C6, it's again very easy to solve. You can answer, you can left here also, or if you want to answer completely, then 20 C6 can be, this is 20 factorial divided by 6 factorial into, here it is 14 factorial, NCR. Hopefully you remember the formula. If you not remember, then watch the video on the permutation combination. This is what actually 20, 19, 18, 17, 16, then 15, then 14 factorial we are cancelling with here. Okay, so I'm not going to write it. Then here 6, 5, 4, 3 and 2. So whatever you can cancel, see this is 5 into 3 15, say this 15 you can cancel, right? And whatever you can cancel, see 6 3s are 18 you can cancel, and you can cancel here 5 4 jar 20, or we can cancel this 8. So what is the situation here? That is 5 into 19 into 3 into 17 into 8. So if you do this multiplication, what you are getting here? So here we get this one 38760. You can do this calculation by your own. So yes, what you are getting after that here? So here we are getting the exact answer is 1 upon 38760. This is the answer. So hopefully it's clear to you. So easy questions simply we have to do in this way. Fine. Okay, so now this question number 12 here. In this question, if you see, we have to check whether the following probabilities given in the question P and PB is consistently defined or not. Okay, so when we are saying this is consistently defined, if it's follow the probability conditions, then it will be consistently defined, otherwise not. So see, before that, let me draw the Venn diagram so we can understand this easily. Let us suppose this is here we have the simple space, right? And here we have the two events, PA, and other events is here what? PB. So PA and PB are the two events, PA and PB. Okay. Now see, this is what? This is the intersection portion. This is the intersection portion that will be in the both, right? So what is this region? So this is the intersection region. This is actually your A intersection, B is showing. Fine. So if we look the value of first one, that is given to us as probability of A is equal to 0.5. Fine. Probability of B is equal to here 0.7. Okay, good. And probability of A intersection B is 0.6. Now see, here is the problem. If you look to this data, probability of A intersection B is 0.6. Is it possible? Because see, A intersections B is what actually? This is the common value in A and B. So because of A intersection B is the common value of A and B, so how it can be greater than A? Because A intersection B will be coming from A only, because this is the part of A. It maximum it can be A. If you are taking the maximum to maximum value, it may be A, but it cannot be greater than A, because A intersection B is the value that is coming, that is the common value of A and B. So how it can be greater than that? You can see that in the region also here. So this region you can see. So is this region can be greater than A? No, because this is the region. This is in the A and B. Yes, maximum it may be like that. That B is fully inside the A, or both overlapping. If the both same sets are there, then max to max it may be A, but it can't be greater. But it is given here. It is 0.6. That is the greater than A here. So this is really not possible, right or not? See here, because of the probability of A here, this is given that less than the probability of A intersection B. This is not possible. This is not possible. The probability of intersection or the number of element in the intersection will always less than equal to number of element in the A. You can remember this one, that the number of element in the A intersection B will always less than equal to NA. It can't be greater, right? It may be equal, right? If A intersection B is equal to A, then but it can't be greater. So similarly, if you are dividing both the side here by total number of sample space. So you can get this condition that A intersection B divided by sample space here is always less than equal to n of A divided by sample space here. So what is this you are getting? That is the probability of A intersection B is always less than equal to probability of A. It can't be greater. So in this case actually you can say that your first statement is not consistent. This is not consistent. This value is actually this data is not consistent data. Okay, let us see the second one. So second data, if you look over here, second data, so that is your PA is equal to 0.5, perfectly good. PB is equal to what it is given, that 0.4, okay, no problem. And the probability of A union B is given to us as 0.8, fine. So yes, it may be right. So probability of A union B may be greater, that is PA plus PB minus A intersection B in this case. So that is actually the perfectly fine, right? You can, if you want to find the intersection value here, you can calculate. See, probability of A union B is what actually? That is the formula PA plus PB minus probability of A intersection B. So we can calculate the value of A intersection B from here. So what is the value of A intersection B? So probability of A intersection B is actually, that is PA plus PB minus probability of A union B. We have all the value, put it over here. That is 0.5 plus 0.4 minus 0.8, that we are getting 0.1. You can clearly see here that is the intersection value is actually less than A and B. So yes, it is acceptable, no problem here. So probability of A intersection B is 0.1. So it's consistent. So no problem at anywhere. So you can say this data is consistent. So this given data here, given data are consistent. There is any no problem with the consistency of this data. So hopefully you get the concept how we are checking the consistent and inconsistent, right? Fine. So if you want to note, you simply pause the video and you can note it, because here I am making the video. So if I wait, so video will be so long. Already its size is quite large because of the good quality I always maintaining, right? So you pause the video, you can revise the video, you can watch so many times. You have option no limit in watching the videos. So the same thing I am not repeating in the video. Okay, so thank you so much. We meet in the next video. Thank you.